What's up, everyone? In this video, we're going to be talking about equations of circles. Now, in this course thus far, we've seen equations when we were creating the equations of a line. So there were two different formulas that we could have used for the equation of a line. Remember, we had slope-intercept form, which was y equals mx plus b. And then we had point-slope form, which was y minus y1 equals m times x minus x1. Now, these are just two different ways of representing the same line, but regardless, when we're creating the equation of the line, we had to figure out, like, what are the defining characteristics of a line? The first thing that we needed was the slope of our line, which was our m value. And the second thing that defines a line is a point that it passes through, right? So we needed the slope and we needed a point on the line. Now, once we had these two properties, then we just take our slope and our point and we substitute it into one of these equations, and then boom, we have our equation of the line, right? So it's going to be the same idea for circles. There are going to be some defining characteristics that we need to figure out about our circle, and then we'll be able to substitute it into an equation. Now, before we get any further, I just want to remind you that when we have equations of lines, like something like y equals 3x plus 4, or y minus 3 equals 4 times x minus 1, something like that, right? Remember that x and y stay in the equation. That's going to be helpful for us when we deal with the circle equation. So let's figure out the characteristics that we need before we move any further.
Now, every circle has two basic components. We start with a center point, and we also have a radius of some determined length. And swinging that radius around the center 360 degrees creates our circle.
So the two things that we need for our equation are the center and the radius. Now, this is the standard equation that we're going to use in this lesson for a circle. Now, it looks a little daunting, but we just have to know what the variables stand for. So we have x minus h squared plus y minus k squared equals r squared. Now, this is not given to you on your reference table, so you need to remember this, but remember, x and y are going to just stay x and y, but h and k, these are the coordinates of the center of your circle. So the h value, that's the x coordinate of your center, and then the k value is the y coordinate of your center. And then r, you could probably guess, stands for your radius, right? These are the two defining things. You need the center of your circle and the radius of your circle. Once you have those two things, you substitute those values right into this equation, and there's your equation of your circle. So we're just going to get right into an example. So the first example is going to be determining the equation of a circle that's centered at the origin. So remember, whenever you're trying to come up with the equation of a circle, you need to know the center and you need to know the radius. So I always make my list: center equals, radius equals, and then you just substitute after that. So right now, our center, if it's the origin, you can look at our graph right here, is 0, 0. Now further, what that means is that our h value is 0, and our k value is also 0. And then our radius, in this case, we're going to be able to use the graph to count what our radius is. So remember, a radius goes from the center to any point on the circle, but I'm not just going to pick any point because we cannot count diagonally, but we can count like vertically or horizontally, right? So if I count from here, I get that my radius is 4. I can also count fully horizontally and also get the same thing, right? My radius should always be 4 all around. So now we just substitute. So x minus our h value is 0 squared plus y minus our k value, which is 0 squared, equals our radius squared, which is 4, right? But now when you have x minus 0 and y minus 0, you don't have to put this portion. You can just write x squared plus y squared equals, and then we'd simplify this to 16. Now, in this example, we're determining the equation of a circle that's centered at points other than the origin. So same exact idea. We still need to know what our center is, and we still need to know what our radius is, and then we are going to substitute those into our equation. So our center in this case, if we look at our graph, is at 4, 3. Now what that means is that our h value is 4, our k value is 3, and then our radius, we can luckily use our graph to figure it out. Our radius is going to be 3 units. So r equals 3. And now we go ahead and substitute. So x minus our h value is 4 squared, plus y minus our k value, which is 3 squared, equals our radius, which is 3 squared. Now, one thing I want you guys to notice here is that we have x minus h and y minus k, and our center is positive. So what you should see here is that, like, your center is 4 comma 3, but when you go ahead and substitute it into the equation, it becomes minus 4 and minus 3. So those signs actually flip there for you. Now, when we simplify this, the only thing we can really simplify here is we keep x minus 4 squared plus y minus 3 squared, but we can simplify this value over here to 9. Now, the last type of example is using the equation of a circle to now go backwards. Can we use an equation that's given to us to make conclusions about the center and the radius? Now, these questions are always going to ask you, what is the center and what is the radius? That's just the common theme of circle equations. But it says identify the center and the radius of a circle whose equation is x plus 4 squared plus y minus 1 squared equals 25. Now, I like to just use that little trick here. Like, I know my center points are involved in these parentheses here, and I know the signs are switching. So the center is going to be at negative 4. We have to change that sign, comma, positive 1. We need to change that sign. And then this value here, that's the value of our radius squared. So our radius, some people would go like this, oh, the radius is 25. Woohoo. No. That's the value of your radius squared. So you need to take the square root of this thing here. So radical 25 is going to be what your radius is. So that actually means that our radius is 5. So again, what we did was I know my center is involved with the numbers inside of these parentheses. So we switch the signs over. Our center is at 4, 1. And then we take the square root of this term here. And that gives us a radius of 5. Now, a little recap here for equations of circles. So the two things that we need for the equation is the center, which is h comma k. We need the radius, which is r. Now, for our radius, in these examples in the video, we were able to count it on the graph, but that might not always be the case. We might not even always have a graph. The question might give it to us, or we may have to use prior knowledge to find it. Maybe like using the distance formula or the Pythagorean theorem, or maybe using the relationship between the diameter and the radius, but we have these skill sets here to figure out what our radius is. And again, remember that this equation is not given to you, and when you have your equations, we flip the signs of our center, right? So if your center is 4 comma 3, you would have to flip that. It would be x minus 4, y minus 3, and then remember that this value over here on the other side of the equal sign, that's equivalent to your radius squared.